When you're putting research together, this will help you determine what type of design would best suit your research. So this will go through the types of research for quantitative and qualitative designs. If what we're looking to do is answer a question when we're doing research, we might look at doing experimental design, or what we refer to as a quasi-experimental research, or sometimes a casual comparative it's called. Experimental research sometimes can be called true experimentation. This is when we use the scientific method to establish the cause and effect of the relationship among a group of variables that make up a study. The true experiment is often thought of as a laboratory study, but that's not always the case. A laboratory setting doesn't have anything to do with it. A true experiment is any study where an effort is made to identify and impose control over all other variables except for one. The independent variable is manipulated to determine the effects on the dependent variables, and so subjects are randomly assigned to experimental treatments rather than identified in naturally occurring groups. And then if we do add a quasi-experimental research, also known as casual comparative, this attempts to establish cause and effect relationships among the variables. These types of designs are similar to true experiments, but there are some key differences. So the independent variable in a quasi-experimental research is identified, but it's not manipulated by the experimenter. And the effects of the independent variable on the dependent variable are measured, but the researcher does not randomly assign groups and must use ones that are naturally formed or sometimes pre-existing groups. The identified control groups are exposed to the treatment variable, and they're studied and compared to groups who are not. When the analysis and conclusions are made, the determining causes must be done carefully, as other variables, both known and unknown, could still affect the outcome. When we look at the non-experimental research design, obviously we're not doing running an experiment, right, for non-experimental research design. So when we look at something like that, we want to look at the type of so if we look at non-experimental research, this is a type of research that doesn't involve manipulation, right? So there's no manipulation or control of the independent variable. The non-experimental research, the researchers measure the variables as they occur naturally without any kind of manipulation. So subjects here cannot be randomly assigned to conditions. The research subject is not a casual relationship, but the independent variable cannot be manipulated. The research is broad and exploratory. Usually, for this, we see like the three main types of non-experimental research would be cross-sectional research, correlational research, or observational research. So a research design is just a strategy for answering your research question that we use empirical data. When we create a research design, we're making decisions about the type of research design that you'll use, what your overall aims and approach will be, the sampling methods or criteria for selecting subjects, your data collection methods, the data analysis methods, and the procedures that you'll follow to collect the data. When you have a well-planned research design, it helps to ensure that your methods match your research aims and that you use the right kind of analysis for your data. You might have to write up a research design as a standalone assignment, like you're doing in this class, or it could be part of a larger research proposal or other project. But in either case, you should carefully consider which methods are appropriate and feasible for answering your research question. So here's a few examples of types of questions for exploratory, descriptive, and relational, the type of question, the description or goal, and then some examples for you to read through. When we do experimental design, this is the type of research that uses a scientific approach towards manipulating one or more control variables of the research subject or subjects and measuring the effect of this manipulation on the subject. It's known for the fact that it allows the manipulation of control variables. This method is widely used in various physical and social science fields, even though sometimes it can be quite difficult to execute. Within the information field, they're much more common in information systems research than in library and information management research. Experimental research is usually undertaken when the goal of the research is to trace cause and effect relationships between defined variables. However, the type of experimental research chosen has a significant influence on the results of the experiment. So there's three main types of experimental research. There's pre-experimental, quasi-experimental, and true experimental. The pre-experimental research is the simplest form. It's carried out by observing a group of or groups of dependent variables after the treatment of an independent variable, which is presumed to cause change on the group. And this is further divided into three types. The one-shot case study research, the one group pre-test, post-test research, and the static group comparison. The quasi-experimental research is similar to true experimental research, but uses carefully selected rather than randomized subjects. The time series, no equivalent control group design, or counterbalance design are examples of quasi-experimental research. And then the true experimental research is the most accurate type. And then this is also known as just experimental research, and manipulates a control group towards a group of randomly selected subjects or participants and records the effect of the manipulation. So we classify this into the post-test only group, the pre-test, post-test control group, or the Solomon 4 group. There are some pros and cons of true experimental research. Some of the pros are that researchers can have control over the variables. It can be combined with other research methods. The research process is usually well structured. It can provide specific conclusions, and the results of the experimental research can be easily duplicated. A few of the cons is that it's highly prone to human error. Exerting control over extraneous variables may lead to the personal bias of the researcher. It can be time-consuming and expensive. Manipulating control variables can have ethical implications, and it may produce artificial results at times. A few more things on the quasi-experimental research design. This is used extensively in social sciences as well as psychology. The quasi-experiments resemble quantitative and qualitative experiments, but they lack random allocation of groups or proper controls, so firm statistical analysis can be difficult. Quasi-experimental design involves selecting groups upon which a variable is tested without any random pre-selection process. So let's say, for example, if we wanted to perform an educational experiment, a class might be arbitrarily divided by alphabetical selection or by seating arrangement. The division is often convenient, and especially in an educational situation, this causes as little disruption as possible. After the selection, the experiment proceeds in a very similar way to any other experiment, with a variable being compared between different groups over a period of time. Some of the advantages to this type of experiment, especially in social sciences, we have pre-selection and randomization of groups, which is often difficult, but they can be used very useful in generating results for general trends. So if we study the effect of maternal alcohol use when the mother is pregnant, we know that alcohol does harm embryos, but a strict experimental design would include that mothers were randomly assigned to drink alcohol, but that would be highly illegal, right? Because the possible harm the study might do to the embryo. So what researchers do is ask people how much alcohol they used in the pregnancy, and then they assign them to the groups. The quasi-experimental design is often integrated with individual case studies, And then the figures and results generated often reinforce the findings in a case study and allow some sort of statistical analysis to take place from there. In addition, without extensive pre-screening and randomization needing to be undertaken, they do reduce the time and resources that's needed for experimentation. Some disadvantages, though, without proper randomization, statistical tests can be meaningless. For example, these experimental designs don't take into account any pre-existing factors. So as for the mothers, what made them drink or not drink alcohol during the pregnancy? Or recognize that influences outside the experiment may also have affected the results. A quasi-experiment constructed to analyze the effects of different educational programs on two groups of children, for example, might generate results that show that one program is more effective than the other. These results will not stand up to rigorous statistical scrutiny because the researcher also needed to control other factors that may have affected the results, and this is hard to do properly. One group of children may have been slightly more intelligent, they might have been more motivated, but without some form of pre-testing or random selection, it's hard to judge the influence of these factors. Disadvantages aside, though, as long as the shortcomings of the quasi-experimental design are recognized, these can be very powerful, especially in situations where true experiments are not possible. They're a very good way to obtain a general overview and then follow up with a case study or a quantitative experiment to focus on the underlying reasons for the results that were generated from this study. When we use non-experimental research, this is something that lacks an independent variable. So instead, the researcher observes the context in which the phenomenon occurs and analyzes it to obtain the information. Unlike experimental research, where the variables are held constant, non-experimental research happens during the study when the researcher can't control, manipulate, or alter the subjects, but relies on interpretation or observations to conclude. This means that the method must not rely on correlations, surveys, or case studies, and cannot demonstrate an actual cause and effect relationships. Some of the essential characteristics of non-experimental research are necessary for the final results. Most of these studies are based on events that occurred previously and are analyzed later. In this method, controlled experiments are not performed for reasons such as ethics or morality. No study samples are created. On the contrary, though, the samples or participants already exist and develop in their environment. The researcher does not intervene directly in the environment of the sample, and this method studies the phenomena exactly as they occurred. So we usually see non-experimental research done as cross-sectional research. This is used to observe and analyze the exact time of the research to cover various study or groups or samples. We divide this into descriptive, which is when values are observed where one or more variables are presented, or causal, which is it's responsible for explaining the reasons and relationship that exists between variables in a given time. With longitudinal research, or we do this in a longitudinal study, researchers aim to analyze the changes in development of the relationship between variables over time. And then we'll divide longitudinal research into trend, group evolution, and panel. And trend is when they study the changes faced by the study group in general. Group evolution is when the study group is a smaller sample. And panel is it is in charge of analyzing individual and group changes to discover the factor that produces them. We use non-experimental research when the research question may be about one variable rather than a statistical relationship about two variables. If there's a non-causal statistical relationship between variables in the research question, if the research question has a causal relationship but the independent variable cannot be manipulated, or in an exploratory or broad research where a particular experience is confronted. Some advantages of non-experimental research is the flexibility that we have in the research process. The cause of the phenomenon is known, and the effect it has is investigated, and the researcher can define the characteristics of the study group. A couple disadvantages is that the groups are not representative of the entire population, and there can be errors in the methodology, and that can lead to bias. For internal validity, this is the extent to which a study establishes a trustworthy or cause and effect relationship between the treatment and the outcome. Internal validity also reflects that a given study makes it possible to eliminate alternative explanations for a finding. So, for example, if you implement a smoking cessation program with a group of individuals, how sure can you be that any improvement seen in the treatment group is due to the treatment that you administered? Internal validity depends largely on the procedures of a study and how rigorously it is performed. It's not a yes or no type of concept. Instead, we consider how confident we can be with the findings of a study based on whether it avoids that trap or that making the findings questionable. The less chance there is for confounding in a study, the higher the internal validity and more confidence that we can be in the findings. Confounding refers to a situation in which other factors come into play that confuses the outcome of a study. For instance, a study might make us unsure as to whether we can trust that we have identified the above cause and effect scenario. You can only be confident that your study is internally valid if you can rule out alternative explanations for your findings. So you can only assume cause and effect when you meet the three criteria in your study. And the three are: the first one, the cause preceded the effect in the terms of time. The second one is the cause and effect vary together. And the third one would be there are no other likely explanations for this relationship that you observed. And external validity refers to how well the outcome of a study can be expected to apply to other settings. So in other words, this type of validity refers to how generalizable the findings are. For instance, do the findings apply to other people, settings, situations, and time periods? Like ecological validity is an aspect of external validity, which refers to whether a study's findings can be generalized to the real world. While rigorous research methods can ensure internal validity, external validity, on the other hand, may be limited by these methods. Another term called transferability relates to external validity and also refers to a qualitative research design. Transferability refers to whether results transfer to situations with similar characteristics. So the three elements of control that's required in an experiment we have here are randomization, manipulation, and then your comparison and your control group. When we look at randomization, we look at random sampling and random assignment. So these are fundamental concepts in research methods and statistics. Random sampling refers to the method you use to select individuals from the population to participate in your study. So in other words, random sampling means that you're randomly selecting individuals from that population. The type of sampling is typically done to ensure the representativeness of the sample, which speaks to your external validity, is there. It's worth noting that a sample is only truly random if all individuals in the population have an equal probability of being selected to participate in the study. In practice, though, very few research studies use true random sampling because it's usually not feasible to ensure that all individuals in the population have an equal chance of being selected. So for this reason, it's especially important to avoid using the term random sample if your study uses a non-probability sampling method, such as convenience sampling. Random assignment refers to the method that you use to place participants into groups in an experiment. So for example, you're conducting a study comparing blood pressure of patients after taking an aspirin or a placebo. You have two groups of patients to compare: patients who take the aspirin, which is your experimental group, and patients who take the placebo, which is your control group. Ideally, you would want to randomly assign the participants to be in the experimental group or the control group, meaning that each participant has an equal probability of being placed in the experimental or control group. This helps to ensure that there's no systematic differences between the two groups before the treatment is given to the participants. Random assignment is a fundamental part of a true experiment because it helps to ensure that any differences found between the two groups are attributable to the treatment rather than a confounding variable. So random sampling simply refers to how you select individuals from the population, versus random assignment refers to how you place those participants into groups. And then manipulation, or a manipulated variable, is also known as the independent variable. So this is the variable that you can control and change based on the experiment. The controlled variable remains constant throughout the experiment. For example, if a surfer finds the number of waves that they can surf successfully, the variable remains unchanging. The variables that remain unchanging may be the type of surfboard that they use. That would be consistent because they would use the same type of surfboard every time. Right? Responding variable happens as a result of the manipulated and the control variables. For example, if a basketball player is examining the number of points that they get in each game, the manipulated variable may be their shooting technique. The control variable may be their level of fatigue and the time that they're playing during the day, as well as the response variable is the percentage of shots that they make during the game. And then the control or comparison group, there's a slight confusion between these two terms sometimes. However, we often use these interchangeably. So a control group is a group of individuals who receive no treatment or a standard treatment. And a comparison group is a group of individuals who receive no treatment or an alternative treatment. So there's some similarity between both. If we do not have any treatment for another group, we can call it a control or comparison group. So standard treatment, let's say I conduct an experiment in a public health center in persons with hypertension at home. I want to test whether my intervention, music therapy, is effective in controlling blood pressure. To avoid bias, I compare the intervention with a control group who receives a standard treatment from the public health center, which is received from a medical doctor or a nurse. Let's say they only get a consultation from a nurse as the standard treatment. If you have any other standard treatment, you can add. The alternative treatment, a similar example, I want to determine the effect of music therapy on controlling blood pressure, but I use a comparison group of my study who receive an alternative treatment, which is spiritual mindfulness intervention, which is not a standard treatment from a public health center. It's called a control group if a random assignment of the samples is adequately done. In contrast, if a random assignment is not conducted correctly, then we can call it a comparison group. A random assignment means we blindly assign the sample to an experimental group and another group. So based on the two perspectives, you have to decide which one you want to use. If you use a standard treatment, but a random assignment's not done properly, can it still be called a control group? Or if you use alternative treatment, but a random assignment is adequately done, can it be called a control group as well? Definitely. You cannot combine both perspectives. You just need to hold one. So for me, if I use standard treatment and random assignment, then I call it a control group with true experiment. If random assignment is not done, I can still call it a control group, but with a quasi-experiment. However, you need a rationale for why the random assignment cannot be done or undone, and other criteria of the true experiment should be met. Similar to a comparison group, if I use an alternative treatment and random assignment is done properly, I still call it a comparison group with a true experiment, and if not, I call it a comparison group with quasi-experiment. So basically, I use the first perspective with a different type of experiment. Some strengths and limitations to lab experiments. It's easier to replicate laboratory experiments because there's a standardized procedure that's used. They allow more for precise control of extraneous independent variables. It allows a cause and effect relationship to be established. A couple limitations of lab experiments is the artificial setting, right? They can sometimes produce unnatural behavior. It doesn't really reflect real life. Means it would not be possible to generalize the findings to a real life setting. The demand characteristics or experimental effects sometimes bias the results, and they can become the confounding variables. Field experiments, though, are done in everyday environments of the participants. We can still manipulate the independent variable, but we do this in a real life setting, so we can't really control the extraneous variables. A couple strengths is that the behavior in a field experiment is more likely to reflect real life because it's of its natural setting. There's also less likelihood of the demand characteristics affecting the results because participants may not even know that they're being studied. And this, happens when the study is covert. A limitation, though, there's less control over these extraneous variables. That might make bias in the results. It makes it difficult for another researcher to go in and replicate the study in the exact same way. And then, I know I don't have it on the slide, but we also have natural experiments that are conducted every day in the environment of the participants. But here the experimenter has no control over the independent variables. These are just things that happen in real life. So there's researchers, Hodges and Tizards did attachment research back in the late 80s. They compared the long-term development of children who had been adopted, fostered, or returned to their mothers with a control group of children who had spent all their lives in the biological families. And some of the strengths that they found is the behavior of this research. Behavior in a natural experiment is more likely to reflect real life because of the natural setting. There's less likelihood of a demand characteristic affecting the results because they didn't know that they were being studied. They can be used in situations in which it would be ethically unacceptable to manipulate the independent variable. The limitations is the expense and the time consuming. There's no control. It makes it difficult for other researchers to do this as well. But with the research that was done here, they followed the development of 65 children who've been raised. They've been in residential nurseries from the time that they were just a few months old. And is kind of known as a field experiment. But the independent variable is what happened to the children at age 4 occurred naturally. The care provided was good quality, but the carers were discouraged from forming attachments with the children. So by age 4, 24 kids were adopted, 15 returned to their natural home, and the rest stayed in the institution. They were compared with the control group who spent all their lives in their own families. The control group was closely matched to the children in the experiment. For example, in terms of sibling or number, home location, parental occupation, position in family, age, gender, all of that is what they matched with the control group. The children here were assessed for social and emotional competence at 4, 8, and 16. The assessment comprised of interviewing the kids and their parents and teachers and a set of questionnaires. So what they found is at age 4, none of the institutionalized children had formed attachments. By 8, those that were adopted formed good attachments, and their social and intellectual development was better than that of children returned to their own families. Those returned to their natural families or restored showed more behavioral problems and attachments were weaker. And nevertheless, all the children who spent their early years in institutions were more attention-seeking from adults and showed difficulties in their social relationships, particularly with their peers. Some of these children were interviewed again at 16, as was their parents and care workers. They were compared with, a new control group as the original control children were no longer matched, the children in the adopted and restored groups. What the researchers found is that the adopted children still had good attachments, which compared favorably with the control children. Fewer restored children were reported as having good attachments, but the children who had been brought up in institutional care had experienced most instability and showed some difficulties in their later attachments, which just kind of goes back to support Bowlby's work on attachment theory. That attachment at a young age is, crucial to a child's development and speaks to their ability to attach to others later in life successfully. We've talked a lot about your random assignment and different variables and things like that, but as it relates to the beneficence here and the APA Code of Conduct, we see this a lot with medical experiments that are done. So in order to compensate the disadvantaged group, they'll do some kind of equalization of treatments when we're testing different drugs and things like that. But, the idea of or principle of beneficence, it's a moral obligation that we have when we practice in research to act for the benefit of others. And so we have to be able to provide benefits, right? Balancing these benefits and risks and harms. And so we have to follow the moral rules or obligations by protecting and defending the rights of others, preventing harm from occurring to others, removing any conditions that will cause harm, helping persons with disabilities, or rescuing persons that are in danger. There's various threats that we have here to internal validity. So history being one, historical events. This refers to events that occur outside the concerns of any research study. The participants of the study are often subjected to alteration because of the role of various environmental factors that can influence the subjects or participants' overall performance. For instance, any natural disaster can have a substantial impact on the outcome or undertaking of a study. Maturation is a threat that's internal to the subjects. It refers to the changes, either physical, development, emotional, or mental, which can occur over time within the study participants. It deals with the time and with the effect that time has on the growth and behavior of the participants. Factors such as subject tiredness, impatience, boredom, things like that can affect internal validity. Subjects growing older and stronger are influential in reducing validity of the research. In general, one can say that the longer the duration of the study, the greater will be the maturation threat. What's next? Testing effects. The testing one would be repeatedly testing participants using the same measures or influences outcome. If you give someone the same test 3 times, isn't it likely that they're going to do better as they learn the test or become used to the testing process so that they start to answer the test a little bit differently? Regression toward the mean or statistical regression. This estimates the strength of the relationship between the variables under focus. So the threat is posed by the selection of subjects with extreme scores far away from the mean during a test. This means that the subjects that display extreme scores or outliers tend to move towards the mean and natural distribution with repeated testing. For example, when children with the worst reading scores are invited to take part in a related study, the improvements you may observe at the end of the course might be due to the regression towards the mean rather than the course efficacy. The statistical regression threat undermines the objective and effectiveness of the overall study. The instrumentation or measurement, if you change the testing procedure or instrument, you're more likely to observe unwanted alterations in pre and post tests. This is one of the chief reasons that we optimize the testing procedures and standardize the instrument before conducting valid research in any discipline. The attrition, some studies are short, others are long and extensive, but not all subjects participate in the study until the end. Dropping out of subjects before the completion of a study is known as the attrition. For experimental designs involving more than one group, the loss of subjects leads to controversial inferences, and then the reduction in the sample size due to any reason is one of the major threats that we have to internal validity. And then environmental factors. We obviously don't always know the conditions that may change during testing. Sometimes location of where people are living changes, and they might move out of the area. Natural disasters could be part of the environmental threats that where people are living. They could also be something like, the time of day, the temperature in the room, the size of the room, so more simplistic things like that could be related to the environment as well. All the threats that we face when we're looking at internal validity risk the research, being able to back up and support the research findings. So we try and minimize the threats that we could potentially have, to be able to support the research. These are just a few more descriptions of history effects, maturation, and testing effects that you can read through. And another description of regression toward the mean, or statistical regression, we call it, and the instrumentation and measurement you can read through. And the attrition, threat to internal validity, as well as the environmental factors. Some more information to read through. So for threats to the external validity of research, we look at 4 subcategories. The first one being population validity. This evaluates whether the sample population represents the entire population and also whether the sampling method is acceptable. For example, an educational study that looked at a single school cannot be used to generalize, children at every U.S. school. On the other hand, a federally appointed study that tested every pupil of a certain age group will have exceptionally strong population validity. But due to time constraints and costs, most studies lie somewhere between these two, so researchers will pay attention to sampling techniques. Experienced scientists ensure that their sample groups are representative as possible, striving to use random selection rather than convenience sampling. Ecological validity is the degree to which the behaviors observed and recorded in a study reflect the behaviors that actually occur in natural settings. This type of validity is associated with generalizability. This is essential to the extent in which findings from a study can be generalized or extended to the real world. In virtually all studies, there's a trade-off between experimental control and ecological validity. The more control psychologists exert in a study, typically the less ecological validity, and thus the less they may have that they may be able to generalize. For example, when we take people out of their natural environment and study them in a lab, we're exerting control, but then we're limiting how much we can generalize the findings to all people in natural settings. For the temporal validity, this enables you to track periods for real-world validity. Valid times can be set by users and applications for data, and data can be selected by a specific valid time or valid time range. Applications are often note the validity or effectivity of a fact recorded in a database with dates or timestamps that are relevant to the management of a business. So for example, the hire date of an employee in human resources application, this can determine the effective date of coverage in the insurance industry because it's a valid date, but it's in contrast to the date or time at which the employee record was entered in the database. The former temporal attribute or hire date is called the valid time, or VT, while the latter date, which is when it was entered into the database, is called the transaction time, the TT. The VT is usually controlled by the user, and the TT is system managed. And then the last one, the outcome validity, is what we are looking to understand from the study, right? So what is the validity of the outcome measure? You know, what is it that we want to know? Is the results measuring what they were intended to? You know, if we were going to, you know, test students on, you know, the SAT, we would, you know, give them an SAT, right? So the validity of an outcome measure is tested by comparing the results of the outcome measure or target test, you know, to a gold standard or criterion test. If the target test measures what it was intended to measure, then its results should agree with the results of the gold standard or criterion test, right? And yeah, so that circles back around to the, you know, other types of validity, like the face validity and the construct validity and the content validity, and back to looking at reliability and validity in general. And to wrap this up, we have mundane and experimental realism. Mundane realism is a measure of external validity, or the extent to which experimental findings can be generalized to the real world. It likes to ask the question, how close to real life are the materials and procedures used in a certain study? For example, a study on memory would ask participants to memorize a list of 3-letter nonsense words. A test of mundane realism would ask, how similar to real-life memory tasks is the activity? Can the findings of such an experiment be applied to real-life memory tasks? And then for experimental realism, this is a term that's sometimes used in social psychology to denote the attempt to capture the essential elements of a real-life situation in an experiment, or in an experimental form, rather than trying to reconstruct the real-life situation, or mundane realism exactly. All right, and that is going to wrap up this chapter, and then you can see increasing mundane and experimental realism will increase the external validity of a research result. So increasing either one of these or both of these preferably will give us better results in the end.